Hello dear, how are you all? Today in this video we have to solve some problem in hyperbolic function. Hyperbolic function, just like trigonometric function, the value of hyperbolic function in exponential function sin hyperbolic x is equal to e raised power x minus e raised power minus x by 2, and cos hyperbolic x will be equal to e raised power x plus e raised power minus x by 2. Tan hyperbolic x is equal to e raised power x minus e raised power minus x over e raised power x plus e raised power minus x. Similarly, we have to prove the identity sin hyperbolic 2x is equal to 2 sin hyperbolic x cos hyperbolic x. To prove this, we write its right hand side is equal to 2 sin hyperbolic x cos hyperbolic x. We write the exponential function, the value of sin hyperbolic x. You know, value of sin hyperbolic x is equal to e raised power x. We write e raised power x minus e raised power minus x by 2. Similarly, value of cos hyperbolic x, which is e raised power x plus e raised power minus x by 2. After simplification, e raised power x minus e raised power minus x multiply e raised power x plus e raised power minus x. Just as the formula, we multiply x plus y multiply x minus y, mean x square minus y square. We write e raised power x square minus e raised power minus x square by 2, and we cancel this 2 by this 2. We get e raised power 2x minus e raised power minus 2x by 2 sin hyperbolic, which is equal to right hand side. And you know what is the difference e raised power x minus e raised power minus x by 2 and e raised power 2x minus e raised power minus 2x by 2? When e raised power x minus e raised power minus x by 2 is equal to sin hyperbolic x, then e raised power 2x minus e raised power minus 2x by 2 will be equal to sin hyperbolic 2x. Sin hyperbolic 2x, which is the left hand side of this identity. So right hand side will be equal to left hand side. To prove other identity, we write secant hyperbolic x prove secant hyperbolic scale x is equal to 1 minus tan hyperbolic scale x. We now have to prove secant hyperbolic scale x is equal to 1 minus tan hyperbolic scale x. We write right hand side 1 minus tan hyperbolic scale x. The value of tan hyperbolic x will be equal to tan hyperbolic x e raised power x minus e raised power minus x by e raised power x plus e raised power minus x whole square. We separate both numerator and denominator. We will get 1 minus e raised power x minus e raised power minus x whole square divided by e raised power x plus e raised power minus x whole square. After this, we take e raised power x plus e raised power minus x as a LCM. We write e raised power x plus e raised power minus x whole square minus e raised power x minus e raised power minus x whole square divided by e raised power x plus e raised power minus x whole square. After expanding this square, when we expand this whole square, we get e raised power 2x plus e raised power minus 2x plus 2 e raised power x dot e raised power minus x minus e raised power 2x plus e raised power minus 2x minus 2 e raised power x dot e raised power minus x over in denominator we write e raised power x plus e raised power minus x whole square as it is. When we expand e raised power x, when this negative sign multiplied all these terms, we will get e raised power 2x minus e raised power minus 2x, e raised power minus 2x minus e raised power minus 2x. We will get 2 e raised power 0 when this e raised power x multiply e raised power minus x. Bases are same. We have to add these powers which become 0 plus again 2 e raised power 0 divided by e raised power x plus e raised power minus x whole square. 2 plus 2 by e raised power x plus e raised power minus x whole square. We write 4 by e raised power x plus e raised power minus x whole square. We now write 2 by e raised power x plus e raised power minus x whole square, which is the value of secant hyperbolic x. We write here secant square hyperbolic square x. Secant hyperbolic square x will be equal to left hand side. Secant hyperbolic square x will be equal to this. So now we prove this last part, cosecant hyperbolic square x. Cosecant hyperbolic square x will be equal to cot hyperbolic square x minus 1. To prove this, we write its right hand side. Cot hyperbolic square x minus 1. The value of cot hyperbolic square x, you see e raised power x plus e raised power minus x. Sorry, the value of cot hyperbolic x here we write value of cot hyperbolic x e raised power x plus e raised power minus x over e raised power x minus e raised power minus x. This is the value of cot hyperbolic x. So we write value of cot hyperbolic x is equal to e raised power x plus e raised power minus x over whole square minus 1. Similarly, we solve it like previous question. We separate numerator and denominator, and then we take e raised power x minus e raised power minus x as LCM. We will get e raised power x plus e raised power minus x whole square minus e raised power x minus e raised power minus x whole square divided by e raised power x. After simplification, when you open this scale, plus 2 e raised power x dot e raised power minus x minus e raised power 2x plus e raised power minus 2x minus 2 e raised power x dot e raised power minus x divided by e raised power x whole square. When we multiply this negative sign in bracket term, we will get e raised power 2x minus e raised power minus 2x will be cancelled to each other. E raised power minus 2x minus e raised power minus 2x will be cancelled. We will get 2 e raised power 0 plus again 2 e raised power 0 by e raised power x minus e raised power minus x whole square. We will get 2 plus 2 divided by e raised power x minus e raised power minus x whole square. We will get 4 by e raised power x minus e raised power minus x whole square. We write 4 included in this scale. We write 2 by e raised power x whole square, which is the value of cosecant hyperbolic scale x. We write cosecant hyperbolic scale x. This will be to left hand side. In this way, we have proved all these hyperbolic function. Thank you.